Last time I left you with how minerals form, and here are some of the ways, and let's take a look at some of the examples. This is in Yellowstone. Yellowstone is famous for its hot springs, its hot pools, um, and the reason that we have all these mineral deposits is because that water has been underground and it has been in contact with rocks for thousands to millions of years, and it has dissolved minerals out of those rocks. Well, when the water makes it back up to the surface, it cools down. Everybody knows that hot water is more soluble than cold water is. So all those minerals precipitate out, and we get these icicles here. This is called Canary Spring. The colors are from the iron and the sulfur that's in the minerals. That's one example. Then here's another hot spring. And we see all these minerals that are coating these rocks where the water has flowed over and the minerals have precipitated out. And then this is a lava flow in Hawaii. And Hawaii is famous for its olivine crystals. In fact, there's an entire beach called the Green Sand Beach on the southern tip of the big island of Hawaii that's all made from olivine. You can just scoop it up. And if you are an August baby, you know that your birthstone is peridot. That's the gemstone version of olivine. This is sulfur, and the sulfur is precipitating out of these gases, these volcanic gases that are being emitted. Those gases are chock full of sulfur and a variety of other things, so much so that when it makes it to the surface, the sulfur then precipitates out of the gases. That's why you have a rotten egg smell around volcanic vents. Maybe some of you have been to Lassen and seen some of the volcanic activity up there, and you smell that rotten egg smell. That's the sulfur. Last time I told you about how minerals can precipitate out of salt water in shallow oceans or in these dried lake beds. This is Bonneville Salt Flat, place that's so flat that supposedly you can see the curvature of the earth, but it's so flat that they have all of these land speed races there. And here you see some of the salts that have precipitated out of the water. This looks like water, but it's not. What you're seeing is mirage. That's a salt flat. This is at some visitor center on 80, I think in Utah, maybe when you cross over into Utah, or maybe when you cross over into Nevada from Utah. But that's just totally white, and that's a reflection of the sky, so it looks like there's water there. And here's the Great Salt Lake and all of the minerals that precipitate out of it. And we can get minerals that are characteristic of igneous rocks. We can get minerals that are characteristic of sedimentary rocks, and we can get minerals that are characteristic of metamorphic rocks. Some of these minerals are considered to be natural resources, and a natural resource is in a form and concentration that is economically feasible to mine, to get. And they can be minerals, they can be rocks. Well, we know that petroleum isn't specifically a mineral or gas either. So how does that differ from a reserve? A reserve is the part of the resource that's known and that can be recovered at an economically feasible cost. So we might have a resource, but we might not have the resources to mine it. It has to be easy to get to or easy enough so that we don't go broke trying to mine it. And some of the things that will make a reserve a resource is, okay, what are the transportation costs? It might be so far in the back of beyond that it's just unfeasible to get it to market. What are the labor costs? What's the market price? And things can change as technology changes also. What you're looking at here are these gigantic gypsum crystals that were found in a mine, a lead mine in Mexico. They were mining the lead resource, and they broke into this void space and found just this wonderland of these huge gypsum crystals. They're able to grow so large because it's really hot. It's a hot environment and it's humid. In fact, the temperature is so high that people that go in aren't allowed to stay for more than 30 minutes. Their growth might be stopped though, because the water has to be pumped from the mine. And if the water is gone, then that's one of the conditions that the crystals need to continue to grow. So maybe they will just decide to stop mining the lead and just leave these beauties alone. But I doubt it. Here's another picture. These are all crystals. Here's this poor miner right here, and it looks like he's about to be crushed in the jaws of some crystalline beast. Okay, so that does it for this section. The next section will be the properties of minerals.